reduce the time for your time controller till the system gets oscillated. Normally, this is my interpretation. Normally, it is the meaning, okay, watching what the oscillation frequency is, if the system gets running in oscillation, and then get 0.75%, 0.75 or 75% of these parameters as a limit. So that you have at the end 0.8 distance to the amplification gain gap, and 0.75 to the fastest time. Then you have a stable system. And more or less, in this interpretation, I'm doing here the same. I enhance firstly my amplification till I see the system is launching to get unstable, reduce to 0.8 or to 0.75 of this parameter, and then I make the system faster that I come in the unstable position and go back to 0.8% of the, or 0.75% of the original one. And in most cases it will rework. You will see, you have seen the factor was 8.5, the amplification factor was 0.57. Yeah? Remember what the system calculates by themselves. We will see where we will land at the end. It must not be the same. There's every time a little bit of relation between the amplification and the timing. Yeah? It could be different. This is what I said, it depends on your application. Sometimes it's better you have a faster system with not so stiff amplification. Sometimes the amplification is more helpful and the timing is not so well. This you see every time on the following graph, how they follow. Yeah? Especially if you want to have a very fast tick movement, the E factor is very important. Yeah? Because to have a fast system. Yep. If you want to only have an accurate system where you do not have this heavy acceleration deceleration, then it's easier to have the amplification stiff and make the timing slow. But this is really depends on the application. You can play. Yeah? In general, if you are doing this way, what I show you, yeah, step by step at very small steps, it's in a safe way. Normally it will not damage and will be work fine. And looks like very professional if you tell me.
Yeah. Specialist.
Yeah? But you will see, it couldn't be so complicated. You have two parameters. Yeah? Couldn't be so complicated.
Correct.
But of course, I can tell you there are stories of the horse. It's working fine. Yeah? So, and now let's go there a little bit more. Closed loop parameters. So, of course, I say we have here very small parameters. Velocity control 0.1. Let's make it a little bit more stiff. Make it to 0.3 maybe. 0.3. In this case, our system gets automatically hand over these parameters. So it looks like a little bit more stiff. Let's see how it's working. 0.3. It's a little bit more. In this case, put them to 0.4. A little bit feel. Oh, a bit more stiff. Let's say 0.5. So of course they were near our target, really right. But let me see. Oh, not bad. Yeah. So now let them run, or make it easier. We want to go step by step in. I say let's do 0.4. We want to have a little bit more to do. If not, then I'm too fast finished. Yeah?
So just one day.
It depends on what money you want to have. Yes, one day. Oh.
Jan, one day.
Don't too fast.
One day, not too fast.
You must be sell all your value. So, same way, go back here and then let's jump.
That's why customer always looking at us. When do tuning for us.
So, and of course, so this is nothing, so we should get a little bit faster in the system. In this case, go let's make it a little bit faster in the record table.
Stand by.
Oh, let him run. I'm not scared. I will tell you if it I will tell you if it gets problematically. So, but we enhance the
Kalau tak stop, saya tak
let's
nak stop. Tutup kah?
Let's go to 500.
Oh, 5 times.
5 times.
No, this is far away. This is
Far away, still far away.
This is not the problem. Change the record set. Yeah, you see. Much a little bit faster. You can go if you go it step by step, very slow. You cannot do anything damage. You will see motor is talking with you.
Yeah.
Sometimes with noise, yeah. Sometimes with movement, but every time they tell you everything. So and of course this we want to enhance that too. Oh, let's see how it is if I put them to 1000.
Wah, record lah.
Huh?
TikTok.
Fine. So, only one direction.
Yes. Yeah, only one direction.
No.
Change the one, the number 2.
Huh?
Change the number 2. Number 2.
Ah, yeah, this one. Changing two. And then let's go to fine. Yeah. I will not jump on. So, and so now let's see how our graph looks like. Yeah?
Yeah.
Huh?
Oh, yeah.
And you didn't press it.
Oh, yeah.
My fault? Yeah, in most cases, because the human in front of the monitor. So, yeah, of course, there we do not completely follow, but it is clear we have only P controller. So definitely we will have a deviation from the current. Yeah, of course, get this one every time. From the current, we are now here the half amp. Looks so far fine. Position, forget, looks not so bad, but we got more in. And then of course there we have here in the constant speed a deviation. So this constant speed and deviation now we only can get back because of the I parameter. But in this case, let's really see when the system gets unstable. Yeah, to see what is our range. So and then you can go step by step in. I believe it's nice from the movement. It will not really change. It get a little bit harder, but it would not jump back from the table. So okay, we have 0.4. Let's see how it looks like. We will put the 0.5. Normally the motor will talk with you. Probably it tell me nothing, so it's fine. It's well. This
What do
case
you
will
mean
say
by
how it looks like.
No
No sound,
the
okay.
0.6.
No sound, okay.
The sound, okay.
Fine.
I've got sound.
Is there a sound?
Yeah, I've got sound.
Yeah. If you listen there a little bit, now you listen a little
Now
bit.
small sound.
A small sound is coming. Yeah?
Just now-
So
just
we
now
are
the-
nearly at the oscillation limit, 5.5.
Or nearly
So when the starts, when the sound starts, means that it's close to
Yeah,
the
it's close to
oscillation.
the limit. We can see what because you cannot damage the modem. There you see there comes more sound.
Yeah.
Yeah, it's very lovely, so it's not really heavy. Yeah, now it's coming, yeah? And of course, if you overturn, then it jumps. But because of that, we do not have the I factor. The I factor is currently not using, but we have only the P factor, so it's not so sensitive. E is much more sensitive, but of course it's a little bit too much. You see, because if you are switching this off, yeah, and you play there, yeah, you listen, that is nearby, and then currently it's only the P factor, yeah. And you will let them run. This is too much a little bit, but if you let them run, control it, and made their graph, you will see that the deviation from the speed will be smaller, but wait, it's coming, yeah? It's much better because we are harder. Yeah? Of course, we have currently not really a big oscillation, but you see here the wider range of these current. So in this case, we have not changed the closed loop from the current controller. Yeah? This is all the same. It will never change, depends on the load what we have, but you see here is oscillation. This oscillation will listen a little bit. It's too hard for the system. So the total current we are talking about 0.8 amps. Yeah, you know, we have seen if you go faster, it go more. So definitely it's a little bit too much. So if you are watching the parameter by themselves, yeah, it's 1.2. remember we have seen the 0.6 or the 0.57 was what the system calculates by themselves. Yeah, so in this case I say here go to 0.75 area, so 75%. This is the point what we can do, and as I want to use here too, I would say, okay, let's reduce this to, let me say, let the 0.7, yeah? So more or less in this range. Yeah? Sounds much better. Yeah? And now I want to make the system faster. If you're watching here you have this calculation of these both parameters. Currently it's a 7. You remember we had the 85 with the automatic one. 1.6 was in the calculation without of the inertia. Yeah? So you see it's much higher than this one was out of inertia. But in general it looks like so far fine. So now we let them by 0.7. Now let's make the system faster and see how the graph is. But firstly, let's have a look in the graph with this one how it looks like. So it should be better than the one before. But now these gaps should get larger. The frequency here should be smaller because we do not listen. One used. No, it's not so really big difference, but here you see this is much less. Yeah, looks definitely better, but here we have the deviation. So then you can say, okay, now let's make the system faster. Let me erase these first graph. So you can compare with this one. So then go to the parameterization and make the system faster. In this case, step by step. Open one. I really forgot the parameter before. Let's see how it is. We'll see where we're coming. That's too much. Oh yeah, we are here at 70. Let's see how the graph looks like. So definitely if we stop here, yeah, okay, yeah, it's very stiff. Yeah, you go a little more out, you have to listen, but it's really stiff for this one. So and I believe if you are going here in the diagnostics and make it, so first we have to let them run, make a trace. And then let's have a look. So here it's nearly correct. Every time that this is not fully matching. Someone told me how I get these parts on the same level. I forgot.
You can press on two of the graph and then combine.
Yeah, exactly. That's okay. My difference was working. And you see, it's overlaid. Yeah, looks like nearly perfect. Yeah, looks like fine. Yeah, for this part what we have here. If you are watching to the current, how this looks like. Now we're going, peak is 0.6, we have there the oscillation. Now we have no really turning, we can see it can make it a little bit more soft, but in my opinion it would work fine. Yeah, it's a little bit hard, but okay. Parameters here we are at 17. Maybe we can see how it's a reaction. We can make this a little bit harder. You listen, a little bit sounds coming. So of course it's hard before. Now it gets a little bit better from this part. We can make here. Said okay. Then I made here reduce this time here. Should get a little bit better. Oh, not really. Yeah, in this case, or 0.2. So we are here, so I believe it was not bad. I believe the 0.7 is fine. Or maybe this one maybe to 0.6. That sound is better. Maybe we could do it a little bit faster.
More lower, more faster.
Sound is nice, better. Yeah, and can watching how it looks like in the diagnostics.
Ada idea untuk tune kat
Reduce dulu.
CMB pun boleh buat.
Boleh.
Sudah ada idea.
Okay.
Patutlah kita selalu buat acceleration dong. Velocity.
Sebelum ni ubah you pun tak tahu ubah apa kan.
So
Saya ikut.
I believe we are nearly on the perfect one. Yeah. So and then of course then it depends on what we want to do. So we want to get faster now because it's a relative stiff drive now. We can going up our targets for a jump answer. In this case, in the record table, let's say okay. Okay, I should stop. This was not so nice. Let me see. Now we are on the limit, so it would be made a little bit softer. Yeah. So, but so see, it's working fine. Yeah. So on this part. Closely. I made it here. Because this is so mostly the sensitive part. Oh, we had last 3,000, I remember.
Yes.
And so, and I will let the jerk like this coming. I want firstly see how it is working on this level. Ready?
Yeah.
Ah.
Oh, it's fine. More. Now we enhance the jerk. I think it's fine. Of course, could we get more? Yeah, let me stop. So, but of course, what we have currently have the position controller is off. Yeah. But so in this case, we should. Of course, we could see the graph, but I will enhance first my closed loop parameter these position controller. So in this case, it has in reality, of course, normally it should not have an influence. In reality, it has an influence, a small one, because it makes an overwriting of parameters. And let's put it here, the 10 inside. Let's see how this is working. Fine.
Muscular.
Position lah.
Last baru start.
Last baru
Okay,
position.
let's make
Sampai
space.
semua sudah okey kan, baru tambah position.
So velocity.
So position yang less penting lah.
Dia pun cakap velocity penting. Velocity control.
Kalau you rasa you betul position tu sudah betul.
Yeah, a little bit. Listen, I'm stopping because there's other deceleration. The stop ramp. You remember,
yes.
this is another parameter. Yeah, we have to adjust that. This is a fixed one.
Okay.
Yeah, so of course maybe this deceleration is much higher than the 3,000 we have here. This is why it goes there during the stop ramp in the sound, because it goes in the stiffness of the controller. So we have to adjust this emergency deceleration that it matches to this one. This is why if you stop it, you listen there. This yeah, it's coming directly from it. So let's see where we are. So. Current, we are over the nominal one. We are in the overload range. Yeah, but it's fine. Yeah, because we have enough break time here. We have not a big oscillation. This is only the standard one. Looks fine. So not the self oscillation was going. Here, of course, it's zero because it stands still. Yeah, so here we have a current for the constant move. You can every time compare here where we are in the acceleration ramp, and this is the deceleration ramp. This is why we have here these higher current. We are in the overload mode for the motor. Yeah, it should get warm over the time, but it's fine because we have these break times. So far we are not coming to really to the 400, but looks fine. And of course, if you are only observing the positioning failure, yeah, this is perfect. You cannot see anything. And by the way, every time we never see there anything in this part because it's so bad we couldn't be that mostly it's not working. In the current you see something, and maybe if you like the position error, there we are talking about 3 micron. Or 3, no, in this case it's turns, it's 0.003 turns, and we calculate how much as it is, it's very small. Yeah? And of course it could never get to 0. Yeah, because these are 2 micro turns or 3 micro turns, 3,000, no, 100, yeah, 0.00, 1 or 0.225 is our falling error. So in this case, looks fine, looks well. So this could be working. Let me see how we are. What is our target? I believe the 500 should work. He's a strong man. This is fine. So I say, okay, we have reserve. We are over the limit, so in this case definitely we have to take care what's coming there, but we can accelerate, decelerate. So in this case I would say let's make the jerk to the 90,000 we had last time.
This is 900.
900.
The 900,000, yeah.
Nó sọc phẩy.
I think from here I need your help.
Basli, be ready.
So okay, record set. Now let's see how this is working. Ready?
No,
You can, yeah, ready.
another one. No, button please.
What have I made wrong?
No, you just edit.
Okay, change already.
Change already.
No.
Yeah.
Change already.
So
Nice.
but let's see. Oh. Sorry.
Trace.
So definitely we are. You listen to this one. So there will be not totally on the limit of the motor, but here so there we are 3 amps. Is it doubles from the nominal one. So we're really on the limit where we are. We are not coming totally to the 500. Not here. But let's see. Yeah, stop it. Stop it. Okay. So let's see how it looks like. Not helpful. Not helpful. Not helpful. Not helpful. So yeah, there we have a little bit over swapping, but yeah, there we are a little bit out of the limits now. So you see how much current we need for the motor to eliminate these parts. But I believe this one could get better. I want to come to the 500. So in this case, let's see if we could come here to the maybe 4,000.
You
Cái gãy anh.
already bypassed the error.
Error. For testing, okay. Say for testing, okay.
But the system is really stiff. Yeah, the listen is a little bit. So and let's see. Ready?
Over. What sound?
Yeah, this here now here you see it. Yeah. They are not coming directly to this one, but you see here the current. Yeah, so this is in this case the most important one. Yeah, the maximum current is 5 amps, so we are coming here to the limit. Yeah, so in this case the current controller will not get more current inside. So, but of course you see here the oscillation. So in this case the system oscillates. I believe we will not come. We could not get more in the faster range in this case. We should reduce this a little bit. We can play a little bit with the speed controller to make this better if needed. But in general we are it's not recommended to work in this part. Yeah, so we have to get it a little bit lower on the speed, because here we are really on the limit with the 5 amps, so because it's the controller at 5 amps.
4.5.
So it's